Hello children, welcome to channel Sube. Children, today I am going to discuss question number 20 from the MCQ part of 2018 Physics New Syllabus paper. Water at 0 centigrade degrees is continuously fed into a fully insulated boiler fixed with an immersion heater at a constant rate of 1 times 10 power minus 2 kilogram per second. The specific heat capacity and the specific latent heat of vaporization of water are 4.2 times 10 power 3 joule per kilogram per centigrade degree and 2.25 times 10 power 6 joule per kilogram respectively. If the steam at 100 centigrade degrees is to be produced at the same rate as that of supply of water, the power of the immersion heater should be the answers. The first one 4.2 kilowatt, second one 22.5 kilowatt, third one 26.7 kilowatt, fourth one 42.0 kilowatt, fifth one 267.0 kilowatt. So let us draw a diagram for this story. So there is a boiler and it has a input tube which brings water. Water is continuously fed into a fully insulated boiler. So this one is the boiler. So water is coming through this tube to this tank at a rate is given this one 1 times 10 power minus 2. The temperature of incoming water is 0. So in this boiler water is heated. There is a immersion coil, immersion heater. So it is like this. You might have seen in kettles. So it is something like this. That is the immersion heater. It is supplied with current from the AC mains. So water is boiled up to 100 degrees because we need this steam up to 100 degrees and generate steam. The steam at 100 centigrade is to be produced at the same rate. So steam is leaving this boiler at the same rate, means this one kilogram 1 times 10 power minus 2 per second, the same rate. That means what we have to do, first we have to increase the temperature from 0 degrees to 100 degrees. The temperature of this steam is what? 100 degrees. It is given. So first of all we have to increase the temperature of this water in the tank, in the boiler, from 0 to 100. So for that we need to give that water heat. The heat quantity is given by mc theta or ms theta. Specific heat capacity says ms theta 2 minus theta 1 is the heat needed to increase from 0 to 100. Then after that we have to convert this liquid water into steam. So we need for that we have to supply heat this amount given by this amount ml, this equation is the latent heat that should be given to turn liquid water into steam. So this is for to generate steam. For steam, this is for liquid, this is to convert. So this is the total energy we should give per second, because if you use this mass, 1 times 10 power minus 2 kilogram, so that mass totally is converted into steam here at the same rate per second. If we limited the time here per 1 second, if we calculated per 1 second, the time is going to be only 1 second. So this mass is going to be the mass incoming in 1 second, per second, mass per second. Then this one also going to be the same mass. Then we will get the total heat energy that should be given to this system to operate, to make steam in the same rate, should be at the same rate. So to fulfill that, we should give this amount of heat energy per second. Energy per second is what? Power. So the total power is here at the left side, because this right side is per second, we have written per second. The mass we are going to write per second, because that is what they have given. So if you use this mass, so that is per second. So all the quantities here at the right side is per second, so therefore it must be equal to the left side, that also should be per second. The energy per second is what? Power. Energy per second is we call power. So that is what they ask, power. So we can easily find out using this equation. So power equals m is 1 times 10 power minus 2, that is per second, the mass per second. Then S is given 4200, that is 4200. Then what is the temperature difference? 0 to 100. 0 to 100 we have to increase the temperature, then 100 degrees we have to increase. So theta 2 minus theta 1 is 100. Then plus mass is the same, because same rate, they say same rate. Therefore 1 times 10 power minus 2 per second. L they have given latent heat capacity, latent heat of vaporization of water is 2.25 10 power 6. 2.25 times 10 power 6. This we have to now simplify. So minus 2 is cancelled with this 100. So here minus 2 can be cancelled with this 6, and we get 4, 10 power 4. So now B is going to be power, total power 4200, that is only we have cancel these two, plus then 2.25 times 10 power 4, that is all. If we, so the answers are in kilowatt. So kilowatt means 10 power 3. If we converted this into 10 power 3 form, 4.2 times 10 power 3, then this one if converted into 10 power 3, 22.5 times 10 power 3. We reduced 1 because we shift the decimal point from here to here. Then we have to go 3. So that is what here. Here 10 power 4, because from this place we have to go 4 times, then from here 3 times. So if we neglect this 10 power 3, so we get in kilowatt. So how to add this? 4.2. We have to add 5 plus 2 is 7. 4 plus 2 is 6. 2 not, yes, 2. 26.7 kilowatt. We write kilowatt instead of this 10 power 3. Instead of this 10 power 3, we write kilowatt. Here with that 10 power 3, this one is watt. This one also watt, because 10 power 3 is still there. If we remove the 10 power 3, we have to write as kilowatt. So 26.7. Here is the answer, 26.7 kilowatt. Third one is the answer for this question. So let us check the answer sheet. Question number 20. So question number 20, answer is 3. Answer is 3, the third one. Right, children, I think you can understand this. This is not a big deal. It is an easy question. So let us now try some what we call target questions. So children, this one is a so-called tank, boiler. So this one is the heater. Immersion heater. So he is going to replace a new one. So this one is the heating element. This one is the coil. This one is what get red heated when current is applied. So he is going to replace it inside the tank. So here is another diagram of immersion heater taken out from the tank. So the thread is here, the nut and bolt, everything is here. So the plug to which we should supply current is here. So this one, inside this the coil is there. This one is something like, you know that we used to heat a small amount of water for tea making. Children, here is your target question number 1. I changed the question a little bit, but you have to think something is there important. So you might notice that. So try to answer this on your own without looking at my answer. Honestly try this. Pause the video now. Since you have paused the video, now I will try to solve this. So I don't draw the diagram, the same boiler is there, but the incoming rate is a little bit 10 times larger. It has been changed, and also there is a heat loss. So without considering without heat loss, first calculate without heat loss. Consider 1 second. Let us write the equation. So if it is 1 second, so the total power we are going to find out, ms theta plus ml is still steam is being made. So ms theta is m is the kilogram per second incoming rate, 10 times 10 times 10 power minus 2. So S is 4200 with this 10 power 3 together. Then theta is 0 to 100 10 power 2. 100 means 10 power 2 plus m is the same, 10 times 10 power minus 2. L is 2.25 times 10 power 6. So let us simplify. This can be cancelled to this one can be cancelled to this one, and 5 is there, remaining 5, because 1 and 2 I took 1 from here, then altogether 2 is okay. Now 5 is remaining. So 42 times 10 power 3, this 2 zeros and this 1 0, plus here 2.25 times 10 power 5. So since the answers are in kilowatt, we have to write it as 10 power 3 form. If you write it, if you converted this to 10 power 3, so we have to move the decimal point here from all the way here 1 to 5 we have to go. So from here 3 we have to go, then that means 10 power 3. Then all together we have to add this to 42. 5 plus 2 is 7, 6, 267. Without 10 power 3 we can write kilowatt. This one is 267 is without heat lost. So to compensate heat lost, we have to supply 5 kilowatt here. So plus 5 kilowatt we have to supply from the mains. Then 12, 7, 272 kilowatt, 7, 8, 9, 10, 11, 12. So this one is the answer. To compensate heat lost, we have to supply from the mains to the heating element additional 5 kilowatt, because heat lost is 5 kilowatt here. So I think you can understand there's no big difference here regarding to the comparing to the original question. Just a little thing I have added, heat lost. Right, let us go to target question 2. Children, here is our next target question number 2. So try this on your own after reading the question carefully. I have changed the question. Now pause the video, don't look at my answer, honestly do it. Water at 20 centigrade degrees is fed into an ice making system at a rate of 1 liter per second continuously. If ice at 0 centigrade is to be produced at the same rate as that of supply of water, the power of the cooling element should be: specific heat capacity is given, specific latent heat of melting is given, density of water is given. So children, as you have paused the video, now I am going to start. So let us follow the same pattern. The power of the cooling element ice should be produced at the same rate. So let us consider per second, t equals 1 second. Then per 1 second the mass is going to be 1 liter, that is the volume. So since the density is 1000, 1 liter is 1 kilogram. You don't have to calculate, you should remember that, because in chemistry you use that always. Therefore you should have that in your head, even though they have given this density. You don't have to write density equals mass divided by volume, all those things you don't have to do. Then mass is 1 kilogram per second. Incoming water, the temperature incoming is 0, no, 20, 20. So outgoing should be 0, that means to make ice. So we have to supply, we have to remove heat energy ms theta, because we have to first reduce the temperature from 20 to 0. 20 to 0. We have to cool it first. To cool from 0 to 0, from 20 to 0, this amount of heat we should remove from ice, not supply, remove. So to be melted, we should remove furthermore ml amount of heat to be melted. This amount of heat we have to remove per second. Then total energy that should be removed per second is P. So that is what they ask. That is what we call power of the cooling system. So if no heat is wasted, no cool is wasted, no energy is wasted. So we have to simplify this. M is 1 kilogram, so we don't have to write it. S is 4200, so temperature change is 20, plus M is again 1 kilogram. L is given 3.3, 10 power 6. So that is all. So 2 times 42 is 84, then 30, then this one 3 33. Let us no, we have to write in the form 10 power 3. Then we have to move this decimal point 3 times right side, then 1 1 2 3 times 10 power 3. Still 10 power 3 is remaining. So this one we have to convert to the form of 10 power 3, then like this. So we have to remove 10 power 3 now to convert into kilowatt. Still this one is watt. So we have to add this 84, then 3384 kilowatt. We don't write now 10 power 3 because we have written kilowatt. So 3384 kilowatt, this one is the answer. You understand, I think. First we cool water from 20 to 0, then we convert to ice by removing ml amount of heat, removing ms heat amount of heat. We convert. There's no change in state here, but here there's change in state, so the latent heat should be removed. That's all. So let us go to target question 3 now. Children, here is your next target question, number 3. Try it on your own without looking at my answer. This one is easier. Now pause the video. Since you have paused the video, I'm going to start. Only ms theta term we have to consider, because there's no change in state. The power is given by ms theta. We have to only increase the temperature from 25 to 35, 10 degrees. S is 4200. M is per second, because this one is per second. Power is per second. second. So right side also should be per second. Per second 1 liter. 1 liter per second. 1 liter means 1 kilogram. So 4000, no, 42,000, 10 times. Then 42 kilowatt. This one is what? So this one is the answer, third one.